In this lesson, we're going to be talking about the arithmetic sequence, and you can see the arithmetic sequence in the formula that I have below. Let's go ahead and talk about the breakdown of this formula. First of all, it starts with a sub n, and we say the word sub because the n is below the a, just like a submarine goes below the water. A sub n is going to represent the nth term that we are looking for in our sequence. So basically, if we're looking for the fifth number in the sequence or the 200th term in the sequence, we're going to represent this by a sub n. Then that's going to equal a sub 1. A sub 1 is going to represent the first term in our sequence. So whatever the first number is going to be our a sub 1. Okay, and now we're going to get to this variable, the d. This is something called a common difference. A common difference is a numerical pattern that increases or decreases at a constant rate or value that's called the common difference. It either increases or it decreases depending on the sequence. So if you look at the example below here, I have on the sequence 2, 5, 8, and 11. You can see that between each of those numbers, you're increasing by 3, and therefore your common difference will be 3. Likewise, in the second example, I have 6, 0, negative 6, negative 12. You can see that between each number, you're decreasing by 6. Therefore, your common difference is negative 6. Okay, back to our formula here. The n, again, the n is always going to be the same, just like the n in the beginning is also going to be the same n. This is going to be the nth term in our sequence. And then the formula finishes off with a minus 1. That's just part of the formula that we're using. Okay, again, just one more thing before we move on. An arithmetic sequence is different than a geometric sequence. Arithmetic sequences has common differences. So if your sequence is changing by a common number by adding or subtracting, you have an arithmetic sequence. If your sequence is changing by a number by multiplying or dividing, you have a geometric sequence. We're only going to be talking about arithmetic sequence today, so we're only going to be working with adding and subtracting. Okay, let's look at this first example here. You don't need to memorize this formula, although by the end of this lesson you will probably have the arithmetic sequence memorized. We want to determine the nth term in the given sequence. All right, let's look at our sequence here. The first sequence we have is 5, 9, 13, and 17. And you can see here that each time the number is increasing, it is increasing by 4. So that means that our common difference, I'm just going to put a little note over here, my common difference is going to be positive 4. Now, I chose to do the fifth term to kind of show you what's going to happen here. Now, I know that if I added 4 here, if I said 17 plus 4, the next number in my sequence would be 21. We know that, but I just kind of wanted to use this example to prove it to you that the arithmetic sequence works. All right, so let's go ahead and write my sequence down. A sub n is equal to a sub 1 plus d times n minus 1. All right, now we're going to go ahead and substitute our numbers into our formula. I want to know what the fifth term of the sequence is. So I'm going to say that a sub 5. Okay, a sub 5 means my fifth term is going to be equal to the first term in my sequence is going to be a 5. And then my common difference is going to be 4. So I'm going to say plus 4. I'm going to multiply it by n minus 1. Again, n is going to be 5, my fifth term, minus 1. From here, all you need to do is simplify it down. So it looks like I have 5 plus 4 times 4. So if I keep using order of operations and simplifying this down, I get 5 plus 16. And it gets all the way down to my answer of 21. And therefore, my a sub 5, or my fifth term in my sequence, is going to be 21. Just as we said earlier. Now, you might be wondering, well, if I know the next term, why do I need to do all that? Well, let's look at the next one. Let's find the 48th term of this sequence. And it's not always going to be the fifth or the sixth or one that you can count to. And I personally don't want to count all the way up to the 48th term or the 368th term. So let's look at this next one. It looks like I have the sequence 2, negative 5, negative 12, and negative 18. So it looks like my common difference, I'm going to write myself a little note here. It looks like it is decreasing by 7 each time. So I'm going to go ahead and write a little note that my common difference is -7. All right, let's go ahead and write out my sequence. My a sub n is going to be a sub 48 because I'm looking for my 48th term. I'm going to set that equal to, my first term in my sequence is 2. My common difference is -7, so I'm not going to write plus -7. We know that a plus and a minus next to each other just means negative, so I'm going to say -7 times the term that I'm looking for is my 48th term, and I'm going to say -1. And then I'm going to go ahead and I'm going to simplify this using my order of operations. You can see here that my multiplication is going to come first in our case here. So we're going to say 2 minus 329. And my a sub 48 is going to be -327. So the 48th term in this sequence, meaning if I were to continue this sequence on for a long time, the 48th term would be -327. Let's do some more. Okay, this time we're going to look for something a little bit different. Before we were looking for the actual term in the sequence. Now we're going to determine the equation of the nth term, and this equation will be able to determine all of the terms that you could possibly want. So let's go ahead and first find the equation. Here's how we do this. When I'm looking for an equation, I still need my common difference. So let's see what my common difference is. It looks like common difference is going to be 9. And it's a positive 9 since we're moving in the positive direction. All right, to determine my equation, I'm still going to use my arithmetic sequence, but this time it's going to look a little bit different. I'm going to start it off by just saying a sub n. I'm looking for the equation of the nth term. Therefore, I'm going to leave it in the nth, with the n, I'm going to leave it there looking for the nth term. I'm going to set it equal to a sub 1, which is still going to be my first term. I'm going to add my common difference, which is going to be 9. And just like I did with my a sub n, I'm going to leave my n in my formula. Because again, we're looking for the equation. Now I'm going to go ahead and simplify it. I'm going to say -8. I'm going to go ahead and distribute positive 9n minus 9. And I'm going to continue simplifying this. I'm going to get 9n minus 17. So the equation of the nth term in this sequence is going to be a sub n equals 9n minus 17. Now here's what that's going to do. In the next question it says, using this equation, determine the 25th term. I can use this equation to say, okay, a sub 25 is equal to 9 times 25 minus 17. 9 times 25 is going to be 225, and I'm going to subtract 17. And therefore, my 25th term in this sequence is going to be 208. Basically, what the equation does is it helps you get to multiple answers faster. Also, for example, let's say if I go up to that sequence, 1, 2, 3, 4, 5, and I want to find the 6th term, I could use this formula to say, okay, well, a to the 6, or a sub 6 equals 9 times 6 minus 17. So my 9 times 6 is going to give me 54, and I'm going to subtract 17 from it to give me 37. It's just a real quick way to figure out multiple terms in the sequence. Okay, let's go ahead and do another one of these, but this time I actually have it going down in the negative direction. It looks like this one has a common difference of -3, doesn't it? Yeah, -3. So now it's just going to change things slightly. I'm still looking for my equation, so I'm going to say a sub n is equal to my a sub 1, which is my first term in my sequence, and my common difference, which is going to be -3. I'm looking for my equation, so I'm going to leave it as n minus 1. And from there, I'm just going to go ahead and simplify it down to get myself my equation. So it looks like my equation is going to be a sub n equals negative 3n minus 1. There is my equation of my nth term. Now I can use that equation to find my 50th term. Now I didn't need to find the equation to find the 50th term, but it's just kind of a faster way to do it. So let's go ahead and say a sub 50 equals negative 3 times 50 minus 1. So that's going to be negative 150 minus 1. Therefore, my a sub 50 is going to be negative 151. And again, I could use the same formula to figure out the next term in this sequence. I could say, okay, what's my fifth term? A sub 5 is equal to negative 3 times 5 minus 1. I could do that real quickly. Negative 15 minus 1. And that will be negative 16. So my a sub 5 would be negative 16. I know I just kind of added that, but I just kind of wanted to show you that that is what the equation is helping you do. All right, that is the end of our lesson on the arithmetic sequence.